Greetings, grade 8 students. This is Miss Muntaha speaking. So this is week 6 of online learning, and today we are going to do some extra exercises on chapter 2. We are going to start with exercise 1. We measure out the volume of oxygen consumed by an adult as a function of running speed. The adjacent document shows the obtained results. Question number 1, change the line graph into a table. So the running speed is going to be on the first row and the volume of oxygen is going to be on the second row. So we have 13, 15, 19, and 23 kilometers per hour, and respectively we have 20, 40, 50, and 60 milliliters per minute per kilogram. And of course, we are having a title for the table that we drew. Table showing the variation of the volume of the consumed oxygen as a function of running speed. Question number 2, analyze the results and draw out a conclusion. So we're going to start with the y-axis. The volume of the consumed oxygen increases from 20 milliliters per minute per kilogram to reach 60 milliliters per minute per kilogram as the running speed increases from 13 kilometers per hour to 23 kilometers per hour. What do we conclude? We conclude that the volume of oxygen increases as the running speed or physical effort increases. Exercise 2. This exercise represents the variation of the quantity of glycogen in a muscle according to the type and duration of physical exercise. Change the table into a graph including all the variations of the quantity of glycogen. These are the variations according to the type of activity, and of course we have to include the time. So we have the title of the graph. We represent 3 color codes, one for the person at rest, one for the person during light exercise, and one for the person during intensive exercise. So for the person at rest, at T0 it's 15, at T30 it's 15, at T60 it's 15, so the line is going to be straight. Whereas during light exercise at T0 it's 15, at T30 it's 13, and at T60 it's 11. For the person during intensive exercise, it's 15 at T0, 7 at T30, and 1 at T60. Let's interpret the following results. So we're going to do every line graph alone. So when the adult is at rest, the quantity of glycogen remains constant at 15 grams per kilograms within 60 minutes. Whereas for the person performing light exercise, the quantity of glycogen decreases from 15 grams per kilograms to reach 11 grams per kilograms within 60 minutes. Whereas for the person performing intensive exercise, it's going to decrease from 15 grams per kilograms to reach 1 grams per kilograms within 60 minutes. This means that as the intensity of exercise increases, the use of glycogen by the muscle increases because it needs more energy. Let's change this table into a histogram. So of course the histogram also should have a title, and we're going to do the same color code. So at rest it's 15 at T0, during exercise it's 15, during intensive exercise it's 15, so all of them are 15. Now at T30 for at rest it's 15, for light exercise it's 13, and for intensive exercise it's 7, and for 60 minutes at rest it's 15, at light exercise it's 11, and at intensive exercise it is 1. Number 4, indicate the utility or the usefulness of glycogen in the performed exercise. So glycogen is the stored form of glucose, and we store it in our muscle cells. So during exercise, muscle glycogen is converted back into glucose because we need the glucose for energy, which muscle fibers can use as a fuel in order to keep performing. If you have any question, I would be very glad to answer you. I love you all. Please stay safe.